Hey, all right, we're back with some more logarithms here, except it's going to look more like an exponent problem. How's Hardy bringing logarithms into this? Well, let's find out. So some exponential equations can be solved by equating the exponents. What? Okay, equating the exponents, which means set the exponents equal to each other. Once you rewrite with a common base, aka the base method. This is where I could get my voice real low in the back. No, never mind. I'm trying to act like a goof. So, in other words, we have to have a common, an equal, a same base. So, for instance, here, 6 and 216 are my bases, but they're not the same. So typically what we're going to do here is we are going to try and figure out, hey, is there a number I can take the smaller of my bases to get the bigger one? So like maybe I grab my calculator, I'm like, okay, 6 squared, that's too small. 6 to the third, 6 to the third is 216. So what I'm going to do is I'm going to change the 216 into 6 to the third. Because now my bases are the same. Okay? And once my bases are the same, at this point, because of logarithms, because of if I want to get rid of these 6s so I can set these equal to each other, I would just take the log of that base as an inverse. You're like, Hardy, do I really have to show that step? I mean, if you know what that means, that's fine. I don't care. But once the bases are the same, we're just setting the exponents equal. And now we're doing regular algebra. Add my 7 and divide. And get my answer. Okay? Now, here's one thing though. Okay? You may have to change one or both bases. Sometimes just messing with the smaller one and taking it to an exponent to get the bigger one won't work. Okay? So sometimes we're going to have to get a little more creative. You're like, that's going to be the next one, isn't it? Yep. Because I look at the next one, I'm like, okay, so 4 squared. Oh, wait, Hardy, 4 squared is 16. Oh, Hardy's head's in the way. There's a shocker. 4 squared is 16. And so how am I supposed to get to 8? This is one of the situations where I'm going to have to use a number that's smaller than both of these and try and figure out if I can come up with an exponent to get to each of them. So I'm like, 4. What can I do with 4? What else can I do with... Oh, 2 squared is 4. Okay, let's try this. So 2 squared, can't lose my 3x there. Can you think of something 2 to some power that would get me 8? You're like, well, 2 squared is 4. Oh, 2 cubed is 8. Okay. So see what I did. I turned 4 into 2 squared. I turned 8 into 2 to the third. I had to change both of my baby bases. But it did give me the opportunity to make them equal. And again, since these are notes, I'm going to write out what we're actually doing, so we're not just making the assumption here. The log of that base. And now what's left up here is my algebra problem. And again, the parentheses are critical because I don't want this to be 3x plus 1, because that's not what that is. That 3 has to distribute, which is why I wrote it out, so we'd have to think about it. So I get that done. And now we just start, subtract my 3x over, divide by 3. Okay? So sometimes it's just mess with the smaller base. And if messing with the smaller base doesn't work, we got to get smaller. And typically, that base number is probably going to be 2 or 3 most of the time. It's going to be something really tiny. It's not going to be something huge. So we just got to mess with it a little bit, okay? But sometimes it's going to take one step further of crazy. It's crazier than this where I got to change them both. Yeah. Sometimes you may not get a common base. I mean, you get something like this next one, 2x equals 7. I can't take 2 to some power and get 7 unless it's some crazy decimal. So here's what we're going to do instead, okay? First, whatever your base value is, okay, with the exponent, that's got to be isolated before you apply a log. So like in the first one, it's done. In the second one, I would have to get that alone first, okay? In this one, I would have to get that alone first. So once I do, here's what I've got to keep in mind, okay? Reminders of some things. A log and its base are inverses. They are opposites. So here, if I want to get that 2 out of there, I can't divide it. That's not 2 times x, it's 2 to the x power. So what I have to do is I have to take the log of that base, and if you do it to one side, you have to do it to both. This is algebra, of course. This is the same thing as if I'm adding to both sides, subtracting to both sides, doing whatever I do. So log base 2 and 2 are inverses. They cancel, just leave me with x. And then this side, since I don't know 2 to what power is 7, remember, we're going to do change of base. Log big divided by log little. We're going to get decimally stuff, but the calculator is going to do the decimally stuff. I don't have to worry about it. So like 2.81. Then I can always go back and check. I mean, you don't have to do this, but I'm just curious. 2 to the 2.81 power. Again, with rounding, it's slightly off, but yeah, I basically got the right answer. But again, if your base, whatever has the exponent to it, is not isolated, that's got to be done first. Okay, now we're in a situation like we were on number 1. I need to get that 10 out of there. How do I undo the 10? I use the log. Again, to both sides. So you can, I would just get the change of base done first. Log 16 divided by log 10. So 2x equals 1.20. Divide by 2. We actually had one extra step this time. X equals 0.6. And we move on. So once I can isolate my base and get the log in there, now it just becomes algebra 1. So you're like, on this last one, this is kind of weird. So why can't I keep the 5? Because the e is what's being taken to the exponent. There's no parentheses. That 5 isn't part of what's being taken to the x plus 3 power. So here, we're going to divide by 5 first. Now we need a reminder again here. Quick reminder lesson. E, do I put log e? No. E and natural log are inverses. So here, to get the e out of there, I'm going to take the natural log. So x plus 3, and then reminder, at least on the calculators we use, the natural log's right next to 4 here. So the natural log of 9, that's going to be 2.2 because of rounding. And then we minus the 3. And yes, you can get negatives for these. Okay, they're exponents. Exponents can be negative. So kind of interesting, isn't it? It's very much like your algebra, except when, of course, you're getting the log taken care of. So that is it for part 1. As you're like, Hardy, did you misplace your stuff again? No. Okay. So we talked about expanding and condensing. So now we are going to be dealing with solving the exponential equations. And again, we're just looking to do our opposite. So here, 3 to get to 243. Hardy with a sneaky little extra help. Like 4. Nope. 5. Yep. So you turn this into 3 to the 5th. And then again, that's going to make things baby bases are the same. And then I'm just going to solve from there. Okay. Or when I'm having to do it on the other one, again, 16, if I try 16 squared, that's going to be huge. That's way too big. Try something smaller. Okay. Maybe you try 2 again. Maybe 2 works. I don't know. 2 to the 3rd. No. 2 to the 4th. 2 to the 4th is 16. So 2 to the 4th. 1 minus 2r. Oh, 64. Holy moly. 5? Nope. 6. 2 to the 6th. And we're right back in business. Okay. And then the other ones are just solving equations. And you're working, and again, you've got answers on the back so you can check as you go, or you can always ask me. I'm always willing to help. So don't go too far away. We are going to be doing a little more with this in part 2 of this section, and that will be coming next.